about 20 computers. Is 20 computers able to process it? Is 30 computers able to process it? How many do I need? And when I use such an environment where I need more than one system in order to process, because my volume of data is so huge, that kind of computing or computation, I call it as distributed computation. Why? Because now I'm distributing my capability across 20 different systems, right? And probably one system is like the master system. All the other systems are like the slave systems, which is it's guiding the system, saying you do this, and you do this. And this is essentially called a cluster of systems. The English word cluster meaning a collection of something. And this kind of computation is called distributed computation. Now, distributed computation could happen in many different forms, right? You could just keep 20 laptops here and try to do distributed computation. But the question then is, how are you going to distribute? Who's going to do what? Which computer is responsible for doing this part of the computation, this part of the computation, and so on? And hence, there needed to be a standard set in order to define that distribution. And that's where essentially we came in with this framework known as the Hadoop framework initially. So this framework essentially defined the way distribution was done. It's an open source framework, and it says there are some guidelines you need to follow. There are certain components that let you use, which will help you make your distribution more efficient. And if you see organizations today, you will see a lot of Hadoop being thrown around throughout the organization, saying, I want to set up a Hadoop platform, I want to set up a big data platform. And that's what they mean. They want to set up a framework, essentially. And Hadoop obviously had multiple revisions it went through. But there are two important components which you need to keep in mind, right? One of the components is known as Hadoop distributed file system, and the other component is essentially known as MapReduce, right? Forget everything else for now. These are the two things you need to keep in mind. And why those two things? The reason is that whenever you deal with data, there are two essential things you do, right? One is you store the data. The second thing is you perform computation, right? So the Hadoop distributed file system is essentially for storing the data in a distributed format. It gives you the capability to do that. And MapReduce essentially gives you the ability to compute the data using certain guidelines and frameworks, right? Saying, okay, one of the computers does this, the other computer does this. And when you put both of these together, they are essentially able to orchestrate how all these things work together in tandem, right? Because it's very important to make all these things work together, right? It's like when you were kids and you were told to run a three-legged race, tie two legs together and make two people run, right? If you didn't have any coordination, you'll obviously fall down, right? It's the same way here. If you don't have coordinations between the system, it's going to crash land, and you're going to sink into a lot of issues, right? The Hadoop.
What is the meaning of MapReduce? So Redis means it will eliminate the duplication of data, or what?
No. So there are two things which is being done, right? I'm not going into the duplication, all of those. That's a different part called redundancy. But what mapping essentially does is it maps maps the data to different systems. It says, okay.
That's one of the SDF also doing, right?
No, so SDFS is just the storage component.
Okay.
MapReduce is doing the computation. So it's going to say, I'm going to map this computation operation to you. You handle that. And what Reduce is doing is, it's after everybody has done their individual computations, Reduce is getting it all together, right? That's why it's called mapping and reducing. So reduction will get all those together, because at the end you need one result coming back, right?
So let's say there are four systems. One system is down. So
Yeah.
you get the data.
Yeah. So that portion is called redundancy, and what essentially happens is, whenever you store in HDFS, it creates a duplicate of the data across two systems or three systems based on how you define it. So if one of the nodes is down or one of the computers is down, it gets the data from the other system, and the master computer or the master node, which we say, essentially knows where different pieces of data are sitting. So we introduce that redundancy while we are storing the data itself. And if you look at the Hadoop ecosystem itself, it's got a lot of other different components to sitting on top of HDFS and MapReduce to do different things, like databases. You have different computation engines, and so on and so forth, right? And you can get this ecosystem anywhere. If you go online and read about Hadoop, it's essentially a standard framework. It's a standard system. Now, this ran for a few years, right? MapReduce and Hadoop HDFS together ran for a few years. But there were some very clever people who came up with something known as Spark. And Spark is basically a computation engine, right? Don't think that, who has heard of Spark here before? Just heard of it, right? So Spark is not a language, right? It's not a language you essentially code in. It's basically a computation engine which does computation in a different manner, right? And the reason this became popular is because of a few things, and I'll tell you that. But Spark was initially Apache came up with Spark, and they created a unified analytics engine, and they said Spark is the most powerful engine which is run today, and it's better than how MapReduce works. And the reason why people started using Spark was because of these reasons in general, right? I'm just going to talk about these reasons in general. Number one is that it's easy to get started. You don't need a lot of different infrastructure set up, a lot of different rules and regulations, guidelines to initially follow to get started. Spark gave you a very easy framework to set up. The second thing is that it distributed workloads. When I say workloads, the computation very easily in a very dignified fashion, across all your different systems. And some of the other things, which you see here, like it had the capability to do exploratory analysis very well. It could work with, your data cleaning and ETL or your extract, transform, load processes, which is part of data engineering very well. It could deal with real-time data very well. And because of all these things, it came up with certain advantages over conventional MapReduce. What were they? It was that even though it is a little more expensive than MapReduce, there are certain advantages which kind of overshadows that. It's claimed to be 100 times more faster than MapReduce, right? So if MapReduce could do 1 million operations a second, Spark could do 100 million operations a second, right? And the reason it could do that was because unlike conventional processing, Spark started doing everything on the RAM, right? And all of you know that RAM is a faster computation engine or a computation device than your hard disk or your SSDs. And that's why all of you essentially say, oh, can I increase my RAM of my laptop from 16 gigs to 32 gigs, or from 8 gigs to 16 gigs? And I started off, and when I had my first system, I started off with 32 MB of RAM. So, and some people even started off lower than that. So, RAM is the one where the main processing happens, and because of that, Spark said, let me do it there, and let me define the guidelines for doing it there. And that's kind of when Spark kicked off. And today, it's overshadowing MapReduce to a very good extent, and people are just using Spark a lot because of these reasons. And what does Spark help unify is that it gets all these things together, right? You don't need to look under different umbrellas to do this. You can do batch processing. So if you have 10 TB of data, Spark can do batch processing on that 10 TB of data very easily. If you have real-time streaming, like videos, sensors, anything, it can cater to that very efficiently. Then you can do a lot of interactive querying, interactive applications with Spark in a very dignified and unified fashion. And the key things which came into light were machine learning, deep learning, and graph processing. And the reason is because that these particular things take a lot of time to do because of the heavy amount of computation. And Spark kind of bridged that gap to saying, if you had something which took 10 days I'll help you reduce that to 2 days or 1 day or a few hours, right? That's why all these things started becoming more popular with Spark, and Spark started building on all of these, as standard libraries, right? So the architecture is similar to how distributed computation works, because Spark works in distributed environment. You have something called as the driver, which essentially is driving everything, right? I'm just going to simplify it down. And then you have something called as the different nodes or the workers, which essentially do the work for you. So the driver is, driving the workers to do the work. It's as simple as that. And there are certain things which you need to set up in terms of, okay, telling it this is a Spark session, so do all of this, and set up those initial calibration before you actually run the whole thing. And that's where this power came into limelight. That's where this power started being used a lot, right? Now, I'm going to skim through this quickly in terms of why Spark, or what are some of the reasons why Spark kind of did things very well, right? Number one is there are two main operations which you do when you're writing codes on Spark, right? You do transformations and you do actions. So in Spark, transformations basically define the operation, right? So for example, if you want to do a plus b as an addition operation, a transformation will just define it. It won't run it. It only runs when you perform an action. So you want to actually do the sum somewhere else, that's when it will do it. So it gives you an advantage of defining the operations first and then doing the actions. So basically lazy learning or lazy running, that's what transformations are called. And the other thing which kind of disrupted the way Spark deals with data is the introduction of something called as resilient distributed data sets, or data sets, data frames within the Spark environment, which essentially use these transformations and actions, and they are distributed. So when data is distributed, you're going to get maximum capacity or maximum value out of it. And this kind of orchestrated that, this kind of gave that more leverage to Spark. Think of the days back when you had an Excel sheet, right? You had 1 column, 2 columns, 3 columns of data. And you ran it, you did a sum operation, it did a sum on 1 column of data. But let's say you want to do a sum operation on 100 million rows of data across 5 computers, right? So distributed data sets kind of became more popular, and then worked on this transformation and action kind of a scenario. Now, this essentially gives you the different kinds of data frames or data sets you can use with Spark, and why RDDs are essentially more useful than conventional data frames which were used in Python or R or whatever language you are aware about.
Can you show me here?
And the other essential advantage of Spark is Spark streaming, and this is vastly used across industries today, is the capability of Spark to do real-time streaming, right? It can do insights from real-time data very, very fast, and Spark streaming is what that is called essentially. So you get in a bunch of data from anywhere you want in real time. You invoke the Spark streaming engine to do any operation you want on that particular stream of data, and then you give some outputs back and push them to wherever you want. And this could do it in real time, right? And that's where the power of Spark was essentially seen, or is seen, right? So for example, if you go to, I think the new CapitaLand Mall, which opened up in the past few months or a few months ago, they have different cameras sitting around everywhere in the building, and they're using those cameras essentially to understand your movement in real time across the entire mall, in order to better understand which board should advertise what, how you should be sent certain information to your phone as push notifications, when and where you should be sent all of those things, all happening in real time, right? This is just the diagram in a little more complete fashion. And just to summarize all of that, the main use case of Spark is essentially all of this, right? What we talked about. streaming, machine learning, deep learning, batch processing, real-time processing. Now, what essentially happened was that Spark came about, but what we didn't have, or what we needed to do, was people needed to be very specifically, knowledgeable about how to set all of these things up, right? Say a few years back, or even today for that matter, you need to be very knowledgeable about how to set it up. And if you didn't know how to set it up, if you didn't have an engineer, right? There's a difference between an engineer, a developer, a scientist, right? If you didn't have an engineer to set this up, then it would take a long time. And that is where, I'll get back to this in a bit. That is where what happened was Databricks, now an organization, the owners of Spark created this organization, right? They moved away from Apache. They said, we'll do something more with Spark. And they created this unified platform which could help organizations set this thing up instantly, right? They said, all you need to do is select a few options, press a button, and we'll create the backend infrastructure for you very quickly. You don't need to bother about the backend infrastructure. And that's where, and a lot of people have not heard about this, but that's where these things are coming to limelight today. If you see Databricks today, you'll see a lot of different talks and conferences happening around Databricks with different cloud vendors and so on and so forth. And it's basically, it provides you a unified platform to do Spark, right? Or to work with the Spark engine. And I'll show you how the terminal looks like, just to flash it up so that you guys can go and try it out. But it's got a few different components. And you can code on the platform like you code anywhere else, right? There is no special technique of coding required. And it is capable of working with Python. It is capable of working with Java, with R, with Scala, with SQL, with Markdowns, with HTML, whatever, all on the same platform, right? All in the same environment. And these are the two companies who are working with Databricks to a very big extent and are collaborating with them. So people who know about AWS and Microsoft Azure, Databricks can be used along with them very efficiently as well. So I'll quickly show you what the platform looks like and what you can do on that using Spark essentially. And I skipped a few slides in the middle, but what essentially I wanted to talk about was that PySpark is essentially the Python implementation on Spark. So you have two versions of Spark, one called PySpark and the other called Spark Scala, where you have two different variations of coding. For those who are familiar with Python, PySpark essentially gives you a Python abstraction or a Python API to code on the Spark engine, so it's more comfortable for you. For those who are more familiar with the Java side, you could choose Spark Scala to code because Scala is more closer to Java than Python. And that's what PySpark is about. The main thing, though, behind each of these is the Spark engine, which is doing all of the computation, right? And these are some of the key features in terms of computation, in terms of parallelization, in terms of being capable of running a bunch of languages and stuff like that, which I talked about previously, right? So let me quickly just flash the platform and then just show you what it can do, and then we'll just close off from there, right? So just give me a second.